Let's take the easiest case. We have a couple of parachutes, Coney Island style, that are both open and start falling together. Okay? But let's have unequal weights. Let's have one parachute like that, the other parachute like that. And this parachute over here is on a kind of a heavy dude here. And this parachute over here is on his little kid sister. Okay? And now they're both coming down. Very heavy, very light. I got a question for you. Which one hits the ground first? Check your neighbor. Through the air. Let me make it really easy. Through a vacuum. Which one hits the ground first? Vacuum. Same. Someone say, yeah, but this guy's a lot of heavy. You say, yeah, but you got a lot of mass. One effect takes care of the other, huh? But now, air resistance acts. Do you guys think the heavy one's going to hit first? How many people say, I think with the air drag, the heavy one guy going to barrel through the air a lot better than the little girl? Show of hands. All right. Nice. Okay. As they fall, the air drag builds up. I'm going to put an arrow for air drag, and I put the arrow acting up. Why I put it up? Why I put this arrow down? Because weight always acts which way? Begin with a D. Down, okay. And the drag, a resistance force, will always be in the direction to oppose motion. Kind of makes sense, doesn't it? So you're coming down through the air, and the air kind of drags behind, and you're pulling. See? So it's a tug-of-war between this and this. And let's suppose these are both going the same speed. And I have this one about like that, okay? But let's suppose this over here, let's suppose this is like 400. And let's suppose the girl here is like 150, okay? Let's suppose the air drag here is 100. I got a question for you. Are both of these people at this instant undergoing acceleration? Check your neighbor. Do you know enough physics to say yes or no? Check. How many people say, you know what? They're both accelerating. I ain't going to say they're accelerating the same, but they're both accelerating. Show of hands. Most of the class. Good. And how do you know? Because there's a net force. And if you got a net, what's the rule? If you got a net force, there's an acceleration. So look at that. They're both accelerating. Now, as they go faster and faster, what happened to the resistance? Bigger or stay the same? The air drag depends on two things, gang. It depends on how big the thing is, how much air is plowing through, and how fast it's going. You're in the car. You're driving the car. Your friend's driving the car. You're going 20 kilometers per hour. You stick your head out the window. Feel the air drag? Now the friend's going 50 kilometers per hour. You stick your head out the window. More or less. Now your friend's going 100 kilometers per hour. You stick your head out the window. What do you get? Dandruff job, right? I mean, that air resistance really builds up. The faster you go, the more the resistance, yeah? Okay. So these people are both going to go faster? How do you know they're both going to go faster? Because they're both accelerating. Okay? Now they go faster until the air drag builds up to. I'm making these both pick up the speed the same. I'm really oversimplifying, gang, just to give you the idea. Now they're going so fast that the air drag builds up to 150. I got a question for you. Do they both continue to accelerate? And the answer begins with an N. Okay? Now, which one ain't accelerating anymore? Why the little girl? What's the net force on the little girl? Zero. What's the acceleration of the little girl? Zero. That means the little girl goes, ding, hangs at rest, right? Does zero acceleration mean not moving? No. Zero acceleration means not changing how you is moving. Okay? So she continued down, steady. Let's suppose right now she's going maybe 30 kilometers per hour. 30 kilometers per hour at this point. Wait a couple of seconds later. How fast is she going? 30 kilometers per hour. How about the dude? He's going faster. He's going faster. He's picking up. She stopped picking up. What's the 50-cent word for stop? Terminate. Her acceleration has terminated. She says, I have reached my terminal velocity. I'm going so fast that the air drag against me, honey, exactly equal to gravity pulling down, it's a wash. The net force on me is 0, so I go steady, 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 all the way down with no acceleration at all. Ain't that neat?